What you see depicted here is known as a pedigree. And a pedigree is a way of analyzing the inheritance patterns of a trait within a family. And it can be useful to understand more about that trait, maybe to make some insights about the genetics of that trait. And it's a way to think about, well, what's happened in the past in a family, and then maybe we can help get some probabilities or get some understanding of what might happen in the future. But let's just break it down so that we understand all of the different parts of a pedigree. So big picture, a circle represents a female in the family, and a square represents a male in the family. If either the circle or the square is colored in, like we see right over here or we see right over here, that means that that person exhibits the trait. And the trait that this particular pedigree is for is the trait of freckles. And whether or not we're colored in, that is a phenotype. That is an observed trait. You just look at the person and say, do they have freckles or not? This male right over here does not have freckles. This female right over here does have freckles. This male right over here does have freckles. But once again, this phenotype, that's the observed characteristic. We don't know exactly the genotype just from this, although we might be able to infer some ideas about the genotype by seeing how the phenotype pattern spread from generation to generation. But just going back to understanding the pedigree itself, when you have a horizontal line connecting a male and a female, it's called a marriage line, and it means that they are coupling up and they are reproducing. They don't necessarily, I guess, have to be married. It's more that they reproduce. So this male and this female have reproduced, and then this vertical line that goes from that horizontal line, that's known as the line of descent. So it's going from that first generation to the second generation. And so all of the people connected to that vertical line at the bottom of the vertical line, these are their children. All of the people who are directly connected to this. And this is known as a sibling line. So this person, and that person, they are all brothers and sisters. You can see that generation 1, they had 2 daughters, one of whom exhibited freckles, and 1 son who had freckles. Now, these other people in generation 2, these aren't children of the first generation. These are people, you could say, who are brought into the family. They either married into the family, or you could just say they reproduced with the children. But that's what's happening with generation 2. And so you can see you have another what's known as a marriage line, but I guess it could be a coupling line, a line of descent. And then they have 2 daughters in this case. So it turns out that freckles is an autosomal dominant trait. And I will explain what that means in a second. Autosomal dominant trait. Autosomal means that it is a trait associated with one of the non-sex chromosomes. We have 23 pairs of chromosomes as humans. One of those pairs determines our sex. The other ones don't determine our sex. So this means that freckles is associated with one of the 22 pairs of chromosomes that do not determine your sex. And dominant means that in general you get 2 versions of a gene, one from your mom and one from your father. And each of those versions of the gene, for say whether or not you have freckles, is known as an allele. And if a trait is autosomal dominant, that means that if you have even just one allele for that trait, that you are going to exhibit the trait. And so, for example, if the alleles for freckles, if capital F is you have freckles, it's dominant, so we write it in capital, and lowercase f means that you don't have freckles. If someone has a genotype of capital F, or capital F, lowercase f, or I guess we could say lowercase f, capital F, if we wanted to think about order, which one you're getting from which parent, well, then in all of these situations, they would exhibit the phenotype of freckles. And we talk about genotype and phenotype in other videos. And of course, the only genotype in which they would not exhibit freckles would be having both of the recessive traits. So with this out of the way, what can we infer about the genotype of this individual right over here? And this individual will sometimes be referred to as individual 1, 2. They're in generation 1, and they are individual 2 in generation 1. Well, we know that they exhibit freckles. So we know for sure that since the phenotype is freckles, they are in one of these scenarios. And these two are frankly equivalent. So this person, we know that they're either capital F, so that would be homozygous dominant, or they're capital F, lowercase f, which are they are heterozygous. Well, let's first think about the situation if they were homozygous dominant. If they were homozygous dominant, that means to every one of her children, she would give one of these alleles, and either of those are dominant. And so that would mean, if this were the case, that all of her children would get at least one dominant allele. Well, if they all get at least one dominant allele, then all of her children would have freckles. But we're seeing a situation where all of her children do not have freckles. 2 of her 3 children had freckles. So this cannot be the case. So this individual right over here must be heterozygous for freckles. So they must be capital F, lowercase f. And what do we know about this individual right over here, the person that she coupled up with? Well, they don't exhibit the phenotype for freckles. So they must be lowercase f, lowercase f. And then from that, you might be able to intuit a lot more about that. And we'll do that in future worked examples.